Okay, this is a lesson on section 10.1, simple graphs of quadratic equations. Um, we're going to start with the easiest graph that you can make, y equals x squared. And anytime you start looking at functions that you've never seen before, you just make a table of values. We'll plug in five values: -2, -1, 0, 1, and 2. Let's see, be careful here because when you square -2, you're going to get a positive value of 4. So -2 squared is 4. The same thing happens if I square -1. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So plotting these 5 points, -2, 4, -1, 1. Let's see. -2, 4 is right here. 0, 0, 1, 1, and 2, 4. You're gonna see these dots form a curve. It's kind of a U-shaped curve. There's some things that we can gather about this curve. Let me show you the next slide that you want to gather. Um, what we have here is something called the parabola. Every quadratic function has a U-shaped graph called a parabola. The highest or lowest point is called the vertex, and there's a vertical line that goes through the vertex. This line is called the axis of symmetry. Um, so if I go back to my original example, the axis of symmetry would be along the y-axis. Here's the axis of symmetry, and then the vertex would be at the point 0, 0. Now, as we graph more of these quadratic equations, you're going to find that certain parameters affect the shape of the graph. And the first one we're going to have here is the number multiplied by x squared. When a is positive, the graph opens up. When a is negative, the graph opens down. And what this says is as the absolute value of a gets larger, the graph gets more narrow. And as the absolute value of a gets smaller, the graph gets wider. Let's look at a few examples to make meaning of this. So I have here the original graph of y equals x squared. Let's first do y equals -x squared. So what we're doing here is we're changing all of the signs in front of the x value after we square it. So let's see, this would be -2 squared, which is -4. This will be -1 squared, which is -1. And then -0 squared is 0. I'll get a -1 here as well, and then a -4. Plotting these 5 ordered pairs: -2, 4, -1, 1, 0, 0, 1, -1, and 2, -4, produce this graph that is kind of upside down. It's actually a reflection of y equals x squared. And what we have here is if a is negative, the graph opens down. So that's an example if we have a negative a value. Let's look at what happens when we have 3x squared. Well, what we're doing here is we're multiplying the output by 3 after we square it. So what we're doing here is we're taking -3 times -2 to the second power. Let's see, order of operation would say that we're going to have to square -2 first to get 4, and then 4 times 3 is 12. All right, and then let's see, 3 times -1 squared. Order of operation says we square the -1 first to get 1, and then 3 times 2 is 3. Let's see, 0 times 3 is 0. 3 times 1 is 3. And then 2 times squared, 2 times 2 is 4 times 3 is 12. So if I were to plot these 5 ordered pairs, let's see how it compares. Let's see, -2, 12 is going to be way off the graph. I won't even put it there. But 3, 3 is going to be here. 0, 0 doesn't change. Let's see, 1, 3, and then 2, 12. So what we have here is a graph that has the same general shape, but it's a lot more narrow than the graph of y equals x squared. And let's see, we could have predicted that. If the absolute value of a gets larger, then the graph gets more narrow. So let's make a prediction for this next graph. If you have a 1/2 in front of the x squared curve, 1/2 x squared, as a gets smaller, the graph gets wider. So this should be a wider graph. Let's just see what happens. What's happening here is I'm taking 1/2 of x squared. So that's 1/2 times -2 squared. Order of operations says we have to square the -2 and get 1/2 times 4. 1/2 times 4 is equal to 2. So plugging in the rest of these values, that's going to be 1/2 times -1 squared is 1/2. 1/2 times 0 is 0. 1/2 times 1 is 1/2. And then I'll get the same value up here. 1/2 times 4 is 2. So I can plot all these values. At -2 for x, I get 2 for y. -1 for x, I get 1/2 for y. The vertex doesn't change, it's still 0, 0. Let's see, at 1 I get 1/2, and then at 2 I'll get 2 for the y. So if I were to connect these with a smooth curve, you're going to see that the vertex doesn't change. It opens up because a is positive, but what you're going to have here is a parabola that's wider than what you would expect. Okay, so to generalize this, what you might notice is that it's opposite of what you would think. As a gets larger, the graph gets more narrow. As a gets smaller, the graph gets wider. Another parameter change is this one right here. Given given y equals x squared plus c, as c gets larger, the graph shifts up vertically. As c gets smaller, the graph shifts down vertically. And another thing we want to realize here is that c is actually your y-intercept. Let's look at a few examples. Let's see, I've given you the original graph of y equals x squared, and we're going to compare this to y equals x squared minus 3. Alright, so let's do the first one, x squared minus 3. So what we're doing here is we're squaring the input and then subtracting 3. So let's see, if x is -2, that's -2 squared minus 3. So what I'm going to have here is 4 minus 3 is 1. If x is -1, that's -1 squared minus 3. That's going to be positive 1 minus 3, which is -2. Let's see, 0 squared minus 3 is -3. 1 squared minus 3 is going to be -4. And then 2 squared is, 1 squared minus 3 is -2. And then 2 squared is 4. Then minus 3 is 1. So plotting these 5 ordered pairs, let's see, -2, 1, -1, -2, 0, -3, 1, -2, and then 2, 1. You have the same shape, it has the same width because a has the same value. Each of these parabolas has a value of 1, so we would say they have normal width. But if I subtract this value of c, it's going to shift. As c gets smaller, the graph shifts down vertically. So c is changing from 0 to -3, so as it gets smaller, you're going to shift this. It's going to be a vertical shift downward. All right, let's take a look at the next one. So what you want to be able to do is predict what happens to the graph of x squared when I add 2 to it. Well, here it says that as we get larger value of c, the graph shifts up vertically. So thinking of the original equation as having a c value of 0, we would think that this is going to shift it up 2 units. Well, let's go ahead and plot some points. Let's see, -2 squared plus 2 is my expression. So -2 squared plus 2. -2 squared is 4 plus 2, which is 6. -1 squared is 1. 1 plus 2 is equal to 3. Let's see, 0 plus 2 is equal to 2, and then 1 squared plus 2 is equal to 3, and then 2 squared plus 2 is equal to 6. Plotting these 5 ordered pairs, let's see, negative 2, 6, negative 1, 3, 0, 2, 1, 3, and then 2, 6. What you're going to find is you have a vertical shift up 2 units. And the place where that is definitely indicated is on the vertex. Here the vertex is at 0, 0, but notice with my second equation it's now at 0, 2. All right, so putting these two concepts together, we should be able to make graphs of these basic quadratic functions. What you want to do is first make a prediction. If I see this graph, I see that a is larger than 1. So that means it's going to be a little bit more narrow. All right, and our baseline is when a is equal to 1. So compared to x squared, this graph should be more narrow than the original parabola. And that's because of this a value. And what we have next to look at is the c value. I will have, let's see, a c value of negative 4. So this should shift down 4 units from the normal x squared curve. But we do want to go ahead and plot a few points. Let's see. I'm only going to plot 3 points. I'm going to plot negative 1, 0, and 1. And this will be a good indicator of where my graph is. So let's see. 2 times negative 1 squared minus 4. Let's see. Order of operations will tell you to square the negative 1 to get 1. 1 times 2 is 2, and then minus 4 is negative 2. Let's see. 0 is pretty easy. That's going to be 2 times 0 minus 4, which is negative 4. And then 1 squared times 2 is 2, minus 4 is negative 2. So I have 3 ordered pairs. Negative 1, negative 2, 0, negative 4, and then 1, negative 2. So if I would connect these with a smooth curve, what I have is a parabola with a vertex at 0, negative 4, and then it's going to be more narrow than the graph of x squared. So my prediction is shown to be true. Let's try one more. Here we would have an a value. The absolute value of negative 1/2 is equal to 1/2, which is less than 1. So remember, a value of 1 is my baseline. If an a value is less than 1, it's going to be wider. This graph should be wider than the original graph of x squared. I also note that this is opening down because it's a negative a value. So these are the 2 parameter changes. There's no c value being added, but since I have a negative 1/2, this graph will be wider than the normal curve of x squared. It'll also open down. So let's just figure out a couple points here to verify that. Actually, let's do 3 points. 0, negative 1, and 1. Let's see. Negative 1 squared is 1 times negative 1/2 is negative 1/2. Negative 1/2 times 0 squared is 0. And then negative 1/2 times 1 is again negative 1/2. Plotting these 3 ordered pairs, let's see. Negative 1, negative 1/2, 0, 0, and then 1, negative 1/2. What we have here is a parabola that's a little bit wider than the normal curve, and it's also one that opens down. There is an axis of symmetry here on the y-axis, but this is the graph you'd be looking at. So going back through these slides, what we're learning today is how to graph an equation of the form ax squared plus c. We learned that the a value does 2 changes. It will affect the width of the graph. It will also determine if it opens up or down. And the c value is a vertical shift either up or down along the y-axis.